Galileo Scientist for the Galileo in Memoriam Conference. Hi, I'm Brother Guy Consolmagno, the director of the Vatican Observatory, and I'm honored and grateful that I've been invited to speak to your colloquium, Galileo in Memoriam, at the Galileo University in Guatemala. I apologize I can't be there in person. Unfortunately, I have to be in Rome for another meeting at exactly the time you're meeting there. And I also apologize that I can't speak to you in Spanish. My Spanish is not very good, and I suspect your English is far better than it would be. I have an interesting story to tell about Galileo, but I'll tell you the bottom line right now. Galileo was a fascinating, complicated, infuriating, and really important scientist, and we have to strip away a lot of the misconceptions about him to truly appreciate who he was, both as a person and as a scientist. And I hope some of the things I'm able to bring up today will do that. One of the things that I think would be useful to try to understand who Galileo was to recognize that he was both a scientist and a media star. Of course, they didn't have television in those days, but he made his popularity and his living writing popular books. There's always been a problem with scientists who are media stars. In America, we've got the examples of Carl Sagan or Neil deGrasse Tyson. They're the ones who inspire a generation of young people to go into science, but they also inspire an awful lot of jealousy and bad feeling among their contemporaries, in part because by popularizing you sometimes draw too much attention to yourself and create jealousy, in part because they themselves get in the public eye for personal reasons, for reasons of ego and vanity that sometimes the rest of us find a little disturbing. Galileo was both. He was a brilliant scientist, and he was someone who drew a lot of attention to himself for things that weren't always his. It's interesting to put Galileo into a certain context to understand who he was and where he was coming from. He roughly worked about 400 years ago. In fact, it was exactly 400 years ago that he began working on the dialogue concerning the two chief world systems, the book that made him famous and eventually led to his trial. Now, he was born, of course, as your conference points out, 460 years ago in 1564. Well, imagine you've got a friend who was born in 1964, who's 60 years old now. That's what Galileo was when he was writing this book that, really sealed his fate, but also sealed his fame. And he was basing it on ideas that dated back to Copernicus, which would be like somebody writing today a book based on ideas that date back to World War II. The Copernican idea was not something new and radical. It had been around for 80 years. Soon after Copernicus and his ideas were published, the Catholic Church started the Council of Trent, a 20-year council where they were looking at, heresies and Protestantism, looking for heresies in lots of places. And nobody at that time ever saw anything wrong with Copernicus. It's not that he was unknown. It just wasn't considered heresy at that time. And so the whole question of why it was considered heresy at the time of Galileo is something really beyond where I want to go now, but it's an interesting question to bring up, not only because, Galileo had already been writing for 14 years, going back to 2010, if you want to put it in modern eyes, but it would be another 13 years after this before he actually gets in trouble for his book. Why he gets in trouble for it is, I say, a totally different question, but one that I think is well worth keeping in the back of your head. It's probably not the picture you've been given of this radical young scientist who upsets everybody with a brand new idea and is immediately stomped on. No, the Galileo story continues even after his trial. He writes his great book on physics in 1638, many years after the trial. I want to take a look at who Galileo was, rather than just the myths behind him. And to do that, I'm going to depend a lot on a particular book, a biography of Galileo by J.L. Heilbron. There are a lot of books out there about Galileo. This one I find particularly well researched, and it's relatively recent. Hilbrun describes how Galileo was born in Pisa, but was educated at home until 11 when the family moved to Florence. Now, your geography has to remember, Florence is the major city in the center of Italy, and in those days it was run by the Medici family, and it was rich because of banking, and it had all sorts of international power, and it was a great rival of Rome, and it was also a great rival of Venice, another wealthy city to the north. Florence was the main city in Tuscany, but the university was outside in the city of Pisa. In 1575, Galileo went to a local monastery. Maybe he even became a novice for a while, but that's where he first learned the arts and astrology, different from astronomy, mathematics, rhetoric, cosmology. He goes back to Pisa in 78. He's 14 years old at that point, and he's trying to get into the College of Wisdom with a scholarship for the poor, but he was too young. 2 years later, he actually gets into the University of Pisa. He's there to study medicine, not because he wants to, because his father wants him to, because it's a way of making money. Medicine in those days depended on astrology and Aristotelian physics. The fact that everybody got the flu in January was due to, the planets were giving their influence, which is why it's called influenza. That's what, medicine was in those days. However, while he's there, there's a mathematician named Ricci who is visiting, gives some lectures on Euclid. Galileo is fascinated by the mathematics and gets Ricci to convince his dad to allow him to change his major. So he continues studying, but in 1585, he quits the university without actually finishing all the requirements to get a degree. He stays in Pisa, though, and does private education at a number of private salons where people would talk about everything from the arts to literature. He would learn perspective, he would learn painting, he would learn to write. He writes poetry, I'm told really bad poetry. Who were the teachers who were teaching him then? We mentioned some names, Borro and Bonamici, who would teach Aristotle's physics, and they were so in love with Aristotle that they wouldn't even allow someone to think about physics in terms of how St. Thomas was trying to Christianize it. They didn't want to do that. On the other hand, another teacher, Benedetti, wrote a book on motion which rejects Aristotle, and Galileo's ideas you can find in this book. Mazzoni, a Dante scholar who's interested in literature, he actually was also editing the index of books. And he wrote a book on motion talking about the errors of Aristotle. Clavius was a Jesuit in Rome who wrote letters of recommendation so Galileo could get a job. He fought for the idea that mathematics, what Galileo loved, was something as good as philosophy, which was a radical idea. People thought mathematics was just useful for making maps or doing calculations. Del Monte got Galileo his first job, and he actually got Galileo a job in Pisa, which led to a job in Padua. The interesting thing about these people is that Borro and Bonamici were rejecting modern ideas about St. Thomas. Benedetti was rejecting Aristotle. Mazzoni was rejecting Aristotle. The idea that Galileo was the first one to say Aristotle was wrong isn't the case. There are a lot of people talking against Aristotle, and Galileo was learning that from the people who were his teachers. In fact, Hilbrun has an amusing anecdote about his education at that time. He writes, Borro had thrown a chunk of wood and a piece of iron which he thought equal in weight, but typically hadn't bothered to weigh, from an upper window of his house. And as often as he did it, he and his students noticed that the wood fell faster, I think he means slower, than the iron. Bonamici obtained the same result in a similar experiment of greater precision. People throwing things out the window, and of course, the story eventually of Galileo with two balls made of the same stuff landing at the same time. But Hilbrun finally comments, Pisa must have been a dangerous place when its philosophers were thus philosophizing. And you got to watch out who's throwing things out of windows. In 1592, Galileo gets a new job up in Padua. Now, we're up in Venice, the great rival of Florence when it comes to wealth, and the university town of Venice is Padua, and Padua is the greatest university of that era, certainly in Italy. So getting a job teaching mathematics there was an enormous coup for Galileo. It also introduced him to this whole new set of intellectuals with lots of ideas. No one in Europe comes before him in knowledge of the mathematical sciences, to quote Galileo. And he points out that there are a lot of ideas that Galileo wrote up in his book that you can actually find in Sarpi's private notebooks. But probably Galileo's greatest friend was Gianfrancesco Sagredo. This was someone who, after he dies in 1620, Galileo remembers by putting him in the dialogue as one of the people explaining and sort of the wise man of Galileo's dialogue and the two world systems. Sagredo also introduced Galileo to the courtesan culture, where there were legitimate courtesans, basically mistresses who, for political or whatever reasons of class, couldn't actually marry these various characters. But this was where Galileo met Marina Gamba, his mistress and the mother of his 3 children. These characters loved being controversial. A friend of Pinelli was expelled from Venice. Sarpi, the crazy monk, was denounced to the Holy Office and eventually excommunicated and almost assassinated. Della Porta was, brought up before the Index. They didn't like his magic and they didn't like his plays. Campanella, who was a mad monk of that time, suffered imprisonment by the Inquisition. Why is it that so many people were being brought before the church? It's because they wanted to be. This was a way of looking good in front of your friends. This was a way where you could say, look at me, I'm so much smarter than everyone else. The most important principle, if you're an Italian and an intellectual and trying to make a name for yourself, was to look good in front of your friends. And being criticized by the authorities was an instant way of looking good in front of your friends. Galileo was more than just a wannabe intellectual, though. He actually had great talent. He was a great mathematician and a pretty darn good engineer. And the great thing that really got him fame was not the telescope, but years earlier, something called the military compass. Now, a compass is not something that points the direction north, the way the English word has it. In this case, it means a device that can be spread out like dividers to measure distances on a map. But if you look at this, you'll see there's all sorts of markings on it, and the motion of one arm against the markings of the other can be used like a slide rule to make calculations. It was called a military compass because the best way to calculate was to use this to figure out how high do you have to point the cannon in order to hit the target at a certain distance away. But you could use that same principle for surveying, for working out the scale of a map, 27 to 1, so this will give you all the different 27 to 1 measurements or whatever the scale of your map is going to be. You could even use it for, converting currency, working out compound interest. It was essentially a slide rule. And here's the clever thing about Galileo. He would build these devices, but of course, after you built one, anyone else could copy the device. But he would not give you the software, the instructions for how to use it. That was copied out by hand for each purchaser, not printed up. There were no illustrations, so you couldn't use the instructions without the instrument. You couldn't use the instrument without the instructions. And this was very practical for Galileo. For about 2 years, the historians point out that he boarded about 16 students plus their servants, coming for private instruction in how to use the military compass and to buy the compass. So, you want to buy the compass? You come to me, you live with me and pay me rent, and of course your servants have to pay me rent, and I'll teach you how to use the compass. At any time, there might be 10 people living in Galileo's house in Padua doing this. They say that the income from the room charges and the fees for learning how to use the compass and selling the compass itself earned Galileo more than his salary at the university. At that time in Padua, 2 of his closest collaborators were Benedictine monks. Dom Girolamo Spinelli and Dom Benedetto Castelli. Castelli was almost like a son to Galileo, a trusted advisor, a personal agent, a collaborator, fiercely loyal as well as pious. So the idea that Galileo is somehow anti-church, that's not the case. Galileo is plugged into the culture, including the church, and some of his greatest friends and supporters were monks. There's another idea that Galileo himself tried to push, which was, we only accept a theory when it can be supported by the data, not on general, this feels good, or on the authority of somebody else. And yet, when you look into his own writings and his own letters, you discover that he was a Copernican. He believed in the Copernican theory 20 years before he actually saw any evidence of it in his telescope. In 1591, Sarpi talked to him about the idea that maybe the fact that there are tides in the ocean are due to the motion of the Earth, that the Earth was moving. This was, exactly what Galileo adopts later on. In a letter to Manzoni, he says Copernicus is more probable than Aristotle or Ptolemy. In 1604, there was a supernova. There's a bright light in the sky. Well, the sky is supposed to be eternal and unchanging. How can this be? This challenged both the Aristotelian and the Copernican systems. Tycho Brahe could work out the fact that you saw the supernova in the same point of the sky, whether you were in one part of the Earth or the other, at one time of the year or another. But the other suggestion was just, that supernova is not in the sky. It's just a flash of air leaving the Earth heading to the moon. The point is that Galileo not only suggested that Copernicus had a good idea, he suggested it so strongly, he believed in it so strongly, that he would reinterpret the evidence of something like a supernova to fit his idea of how the universe worked. I mentioned the Tycho Brahe system. Maybe I should talk about that for a minute. So, Copernicus had the idea that the sun is at the center of the solar system, all the planets go around the sun, and then far off in the distance are the stars, and the Earth spins to make the stars appear to move. Tycho Brahe said, there's a problem about whether or not the stars move if the Earth moves, that I can remove that problem if the Earth stands still and have the sun and all of its planets go around the Earth. That way, you could still have the stars and the Earth in the same connection, but you can have the same observation of planets going around the sun that seemed to be convincing for Copernicus. The big breakthrough in all of this, of course, was the invention of the telescope. In 1609, Sarpi, remember Sarpi, got a hold on one of these telescopes. He looked at it. The Senate of Venice came to him and said, hey, the guy who brought it in said they'd sell us the secret for 1,000 scudi. And Sarpi says, don't bother. Within a month, he'd figured out how it worked. He knew enough about optics that he figured he could make one of these as well. And he figured Galileo was the guy for the job, not because Galileo understood anything in optics, he never did. But Galileo had a lens shop, and Venice, even then, was famous for the quality of its glass. So Galileo could get pure glass, consistent glass, no bubbles in the glass, and he knew how to carve lenses. Of course, Galileo's lenses weren't the perfect shape that we know now. They tended to be spherical, but that was usually good enough. So Galileo produces one of these, builds the lenses, makes a telescope, gives it to the Senate of the Republic of Venice, and he gives it for free. Maybe that was Sarpi's idea. The Republic is so grateful that they give him a lifetime job, and they double his salary from 500 scudi a year, which is what he was getting at the university, to 1,000 scudi. Meanwhile, Galileo has built a number of these telescopes. He takes his best one, which has a magnification of about 20 power, It has 1 inch of aperture, but he only looks through the center of the lens because that's where the shape is the best. And he sees the moon. And he draws pictures of the moon. Now, he's not the first one to draw a picture of the moon. Thomas Harriot in England drew a picture of the moon several months earlier. But you look at Harriot's picture and it's just a circle with some squiggles on it. Galileo had been educated in the arts. Galileo knew how to paint in perspective. And that meant his pictures came alive. It also meant that he understood what he was looking at, a ball covered in mountains. Something that poor Thomas Harriot had no idea he was looking at. Also that December, he looks at the moon and Venus and recognizes that they have the same crescent shape, just like Copernicus had predicted, or is consistent with the Copernican theory. Of course, it was also consistent with the Tycho Brahe theory. What was really new, though, was when he looked at Jupiter and he saw these little dots, eventually 4 little dots, that were moving around Jupiter. And he was clever enough to understand that the dots were moving around Jupiter, not that Jupiter was just passing through a field of stars. Galileo writes this up in a book. He makes these observations in December 09, early 010. The book is published in Venice by March. In this book, he says that the moon has craters and mountains. He sees the phases of Venus. He looks at the Orion Nebula, and he sees stars there. I think he saw the nebulosity as just basically fuzzy stars, not realizing that it actually was a nebula gas. He looks at the Pleiades, and beyond the 6 you can see with the sharp naked eye, he sees many more stars never seen before. He follows the moons of Jupiter as they change their position night by night. And he ends by saying, "Time prevents me from proceeding further, but the gentle reader may expect more soon." The book is a tremendous success, instantly. And what does Galileo do? He plots his return to Florence. Remember, Venice has just given him a lifetime job at double his old salary. But nonetheless, Galileo goes into negotiations with the Cosimo, the new Grand Duke of Tuscany. He's 20 years old. Galileo had tutored this kid when he was in high school. He, in the book, names the moons of Jupiter the Medicean stars because of Cosimo Medici. He dedicates the book to Cosimo. And basically, he's turning his back on his friends in Venice, the ones who had arranged for his rays, which certified that his observations weren't just optical illusions. Cosimo sends a horse-drawn litter to bring Galileo to Florence. By Holy Week of 1610, things are moving fast. Why did Galileo want to move? Well, of course, he has family back in Florence, but he wants to be able to spend his time full-time in research. And he doesn't want to have to teach. He only has to suck up to one person, the Grand Duke, and not all the different oligarchs who were ruling Venice. Tuscany was richer. He thought he could build more telescopes, convince more people that what he was seeing was real. And Cosimo agrees to all of this, and he is named both the court philosopher and the court mathematician, making mathematics equal to philosophy. So, in 1610, he leaves his mistress behind in Venice. He leaves their 5-year-old son with her. He takes the older sister, and the oldest, Virginia, was already in Florence staying with his mother. In fact, his mistress dies 2 years later. Once he gets there, he starts following the Jupiter moons. He sees these dots of light on either side of Saturn that we now know are the Saturn rings. He sees the phases of Venus. And then he arranges to visit Rome and the Jesuits at the Roman College in the spring of 1611. 400 years later, they had a big party there. This is a replica of Galileo's telescope. It's where the American Academy is now. He shows off the telescope to the Jesuits. They write to Cardinal Bellarmine, himself a Jesuit. 4 Jesuit professors of mathematics confirm that, yep, they saw what Galileo said they were going to see. He's made a member of Prince Cesi's Academy of the Lynxes, and ever after that, he will always sign himself Galileo Galilei Lincei, member of the Lynxes. This was the big science club, basically, the Academy of Sciences. At the Collegio Romano, one of these mathematicians praises his book, and there he makes a lot of new friends, including Prince Cesi and another fellow from Tuscany, another fellow from Florence, Cardinal Barberini, who would become Pope Urban VIII. Things are going great. But it's not long before Galileo's insecurity and jealousy raise their head. He hears that another Jesuit, Christopher Shaner, had published a description of sunspots. And he said, I saw the sunspots before Shaner did. Why does he get the credit? In fact, neither of them were the first to see sunspots. It was Thomas Harriot again, the guy who had that terrible map of the moon. But there was an interesting conflict between Galileo and Shaner about what were sunspots. Galileo insists that they are deformities, spots, on the surface of the sun. And this goes against the Aristotelian idea that things out beyond the moon were perfect. Shaner says, well, maybe they're just planets passing in front of the sun. And here's how you could tell the difference of what these black things on the bright sun would be. If they're tied to the sun, then the time it takes to go from one side, one limb of the sun to the other should be the same, whether they're close to the pole or down by the equator, because the sun is moving as one object. If they're planets, then the ones at the top should go faster than the ones at the bottom. This gives you a sort of a picture of that. It takes longer for the one at the bottom to cross the sun. Galileo writes, I have carefully observed the spots on the sun, and they take exactly the same time whether they're high in latitude or on the equator. Therefore, they are not planets. Therefore, they are fixed to the sun. Now, it turns out he's right. They are fixed to the sun. But in this argument about sunspots, what he misses is that the poles actually make one rotation every 35 days, while the equator only once every 25 days. And Christopher Shaner actually reports this about 10 years later. Galileo, if he had actually measured the sunspots the way he measured them, he should have seen this difference. A period of 25 days at the equator versus 36 days at the poles. Because the point is, the sun is not a solid ball. It's a ball of gas. And the gases spin around at different rates depending on the latitude of the gases. Something that, Galileo wouldn't have known, but he should have known if he was actually measuring the way he said he did. Another conflict with the Jesuits comes up just a few years later with a Jesuit named Orazio Grassi. In 1618, 3 comets become visible, and Grassi is the first person to observe them with a telescope. Galileo was sick in bed and never actually got to see the comets. He sees the comet in the sky next to a star. He writes to a fellow Jesuit who also has a telescope by now, up in Germany, who sees the comet next to the same star. Which means it's not just something in the sky over Rome where Grassi is. It means, in fact, because you can see a difference in the moon compared to stars, you don't see the difference between the comet and stars, so the comet must be farther away than the moon. And, this is Grassi's book, and it's quite complicated, but basically he makes the argument. Galileo hates this idea. So Galileo writes a book under the pen name of Mario Guiducci that makes these arguments and says, no, comets are just refractions of light in the atmosphere. Grassi's kind of upset because the whole point of his observations was there was no parallax. They can't be in the upper air. What's more, he argues, actually correctly, that Galileo really doesn't understand how the telescope works. For that matter, neither does Grassi or anybody else at that time, as we'll get to. Galileo is not happy about this, and he spends his time and finally writes a book under his own name called The Assayer, Il Saggiatore. And he dedicates this book to Pope Urban VIII, his friend who has just been elected Pope. And in writing in Italian for a popular audience with a wonderful sense of humor to really cut down Grassi, he derives the idea of science as depending on data, not the received wisdom of the ancients or of other authorities. And then, on his own authority, he insists that comets are up in the upper atmosphere, which of course is totally wrong. But this book is a great success. It comes out around 1622. The fellow who is the censor for the church, who is a Dominican, because the Dominicans and the Jesuits don't get along, the Dominican writes a long poem about how we are going to be honored for living in the same era as Galileo. People will remember us because they will remember Galileo. And of course, he's right. But this is a very, very strong, fulsome praise coming from the official church censor. Galileo is at the height of his fame, and his best friend, or a good friend, is Pope, and everybody loves what he's doing. Now, I mentioned that parallax. I want to talk a little bit more about that because you can see what that really means. If the Earth were actually going around the sun, there would be some stars closer to us and some stars farther away. Why do you think that? Because stars come in different brightnesses. Well, if you looked at a bright star in front of three dim stars as seen from the Earth on one side of the sun, and then wait till the Earth moves to the other side of the sun, those three stars aren't going to be behind that star anymore. They're going to be different stars. Now, the way that I've drawn it here with the stars really, really close, the effect is enormous. The farther away the star is, the less you'll be able to see this. So the question is, how far away are the stars? Galileo thinks he knows how far away the stars are. He makes the assumption that stars are just like the sun. Perfectly reasonable assumption. Turns out it's actually not true. The sun is a star, but the sun's an unusual star. And then he looks in his telescope and he sees a disk. This, even 100 years later, Herschel saw disks of light. And he assumes that's the diameter of the star. And he writes that looking at the diameter of the star that he sees in his telescope compared to the diameter of the sun, it's 1 over 2,160, and therefore I assume that a star of the sixth magnitude, with that width, is 2,160 times farther away than the radius of the Earth's orbit. Which means you actually ought to be able to see, to some extent, in some place, that kind of parallax motion. And Galileo argues that someday we will see it, and then I'll be proved right. There's a couple of problems. The first is that the disk of light you see in the telescope is not the disk of the star. It's an optical effect. Light comes in waves. Now imagine you've got a bunch of waves hitting the opening of a harbor wall. The waves that come through the opening don't just suddenly stop at the edge. They spread out. And anyone who's worked in a physics lab has worked with a shadow box. You can actually create these waves and see how they spread out and even interfere with each other in those wonderful lines. If that's true for waves hitting the wall of a harbor, it's true for waves hitting the aperture of a telescope. The narrower the opening, the bigger the spread. And remember, Galileo has cut away the outer part of his lens because it wasn't the right shape to actually focus the light properly. So he's got a very small aperture, about a centimeter. We now talk about the Airy disk. It was worked out by George Airy in the 19th century. The idea that light from a pinpoint going through an aperture is spread out, and the width of the circle of the light is directly a function of how big the aperture is. The bigger the aperture, the tighter the circle. In those days, of course, telescopes had very small apertures, so there were pretty big disks. That disk of light that Galileo was looking at was not the disk of the star, it was just the spreading out of the light. Notice what I said. The width of the spread depends only on the telescope. The height depends on how bright the star is. So if you have two stars, they're going to have these two bell-shaped curves. The dimmer star only going half as bright as the brighter star, but the width where the light goes to zero is the same in both stars. Now, the human eye is what's looking through the telescope, and the human eye cannot see perfectly down to ultimately faint light. It can only see the brightest of light, sort of like that. So notice that the bright star cuts out at a much wider spot than the dim star. And even if you took a photograph of stars, you'll see that the bright stars seem to have this bigger airy disk compared to the dim star. Well, this fits into Galileo's idea of how stars work. Basically, he says, I notice there are brighter stars and dimmer stars, and that's because the brighter ones must be closer to us, and, there must be a distance of, 2 or 3 times, some stars 2 or 3 times further away than dim stars. It's a whole lot more than that. If we were to find some tiny star, he's talking about the size of the star rather than the brightness of the star, because it's the same thing to his eye. If we could find a tiny star next to, really close to, a bigger star, which is to say a brighter one, that meant that the dim one was very remote and the bright one was very close, then you should be able to see parallax. Is there any place in the sky where you can have a dim star and a bright star right next to each other? Actually, one famous place is the middle star of the handle of the Big Dipper, Ursa Major. This is what it looks like in a photograph, these two stars close together. And that's not really the close star. If you look carefully at that brighter star with a telescope, you can see this in Galileo's telescope, that star is actually a double star. Right there, you have a bright star next to a dim star. Now, we know, in fact, that the dim star is orbiting the bright star, and they're the same distance apart, because we know now that all stars don't have the same brightness. There's a tremendous variety in the brightness of stars. In fact, we now know of the 100 stars closest to the sun by modern measurements, 80 of them are so faint you can't see them with the naked eye. And the really bright stars in the sky are often enormously far away, because there is this enormous range, both in distances and in brightnesses, that Galileo could never have imagined. So if Galileo had actually looked at the middle star of the handle of the Big Dipper, which is, of course, a prominent constellation, he would have seen a bright and a dim star next to each other. He would have seen that Mizar was a pair of stars that could be split. Not only could he have seen that, he did see that. He saw that in 1617. And he never saw a parallax because, of course, his idea of where the stars were wrong. His idea that these stars were, one closer and one farther was wrong. But rather than saying in public, well, this didn't work, maybe I should go back and rethink it, he did something else. He never published his results. We only know that he split this because it's in his notebooks that were not, looked at until long after Galileo's death. Where did Galileo go wrong? Well, he assumed that the stars show disks, not points, but in fact the disks are an illusion. He assumed that the size of the star was equal to the size of the disk, that the bigger stars are closer, that very close stars would show this easy position, and when he didn't get the results he wanted, he didn't publish. But the disks are an illusion. The size actually refers to their brightness, not their physical size. Bigger stars aren't necessarily, or brighter stars aren't necessarily closer. And it turns out the stars are actually so far away that no telescope in the 17th century would have been able to see that kind of motion. It wasn't until the 19th century that it was finally measured. The other foolish thing was not publishing your results, because sooner or later, the truth is going to out. There's something else going on with the whole Galileo affair and the rise of science. With Galileo are three fundamental shifts in how we do science. What's called the Golden Age mentality, the role of instruments, and the standard of proof. Now, anyone who's read the story of the biblical fall knows the idea that there was a Garden of Eden where we knew everything, and ever since then things have been going downhill. Even the Greeks thought that. They had the story of Atlantis. If you lived in Rome during that time, you saw the remnants of the Roman Empire, and you're thinking, how did these people ever build that? We could never have done that. So the common thought before the scientific revolution was that knowledge was perfect in the past. It's faded over time with the general deterioration of everything else. Hey, you talk to an old person, they'll tell you how much better things were in the past. Well, you laugh at that, but you realize that today everybody says, oh, everybody in the past was stupid, and they were a bunch of ignorant savages, and we're accumulating all of this knowledge. Science is going to lead away to a future of perfection. The metaphor in the past was degeneration, now it's growth. That's why whenever you find, ancient people doing clever things, the people who want to believe that are going to say, oh, those must have been ancient astronauts or UFOs or something else. How could the Egyptians possibly have built pyramids? Well, maybe they're really clever people. Maybe they were better at living their universe than you were. I mean, Galileo made lenses. How many of you know how to carve a lens? I don't. Speaking of lenses, think about the role of instruments in discovery. This is, a modern mass spectrometer. Wonderful, wonderful gizmo. I have no idea how to build one of those. If I'm going to do research on the isotopes of meteorites, I need a gizmo like that, built by somebody else, run by other engineers. The telescope was the first example of something like this. You need this rare, difficult-to-use instrument. Knowing how it works was not really already there yet. And you're taking data, looking through the telescope with your assumptions about what you're looking at, coloring what you see. Your good or bad eyesight, coloring what you could see. And using a telescope isn't easy. There's a story about when Galileo was traveling back from Florence to Padua to, pick up his stuff. He stopped in Bologna and tried to show off the telescope, but it was one of those nights where you couldn't find anything, and it was probably didn't have a good tripod, and people trying to look through it said, I don't see a thing. Galileo, you're making this all up. How do you know? The third difference, the conceptual difference, was how you prove whether something is true or not. Aristotle looked at the universe like it was a set of mathematical theorems that could be demonstrated. Galileo claimed that he could demonstrate that the Earth was spinning and that the Earth was going around the sun. Cardinal Bellarmine, when he talked to Galileo, said, until I see a demonstration, a proof that the Earth is moving, I'm not going to believe you. Galileo didn't have a proof, and a lot of his arguments turned out to be wrong. The whole argument with tides is goofy. His argument of, parallax didn't work out. Galileo did have good probable arguments that the Earth was moving, but he didn't have a mathematical demonstration. That change, going from demonstration to probability, would take 100 years or more. Modern sciences will go forward if there's a high probability that we've got the understanding, depending on the empirical evidence, depending on whether or not this fits into the theories that we have before, but always open to the possibility that some new experiment will show we're wrong. Probably Galileo's day just meant that, it must be true because it's in a book. It's only in the 1650s that Pascal and Fermat invent the mathematics of probability, and another 100 years after that before people work out statistics and can say, how likely is it that this measurement that I've made really is telling me what's going on in nature. But underneath all of that is a difference in how you think that the universe works. Imagine you go to your front door every morning to take a look at the sunlight or pick up the daily newspaper, and you see a cat there. And eventually you put out a little bowl for the cat, a little bowl of milk. And one day you open the door, there's no cat. Well, cats are like that. The universe is considered to be an organism. It behaves fairly regularly, but if it decides to do something else, you can't disprove something just because the universe wasn't going to cooperate that day. Modern science says that nature is governed by rigid rules. This is, of course, starts with Galileo, but works further with finally Isaac Newton. You believe something if you get the same result over and over again. Even quantum physics, you still want to have a predictably unpredictable result. Observation confirms the theory because the universe looks like it's a big machine. Those are fundamentally different ways of looking at the universe. Both of them have really serious flaws. But they're assumptions that people make often without even thinking about them. And Galileo challenged all of them. He challenged the golden age mentality that people knew stuff in the back because he's showing you things with his telescope that nobody had ever written about in the book. And notice, in order to push this further, he has to leave the university where this knowledge was to go to Florence, not Padua, to be able to work independently. He used instruments. The instrument, of course, is useless without the instruction, but the instruction is useless without the instrument. That's a new way of doing science that no one else was comfortable with yet. And he was confounding still. He hadn't quite gotten to that standard of proof. He still thinks that he's doing a mathematical demonstration that the Earth is moving, rather than this is the most reasonable and logical way to do it. Because, frankly, you could invent a physics where your center point is the Earth, just like Tycho Brahe had done, and everything else is moving, around the sun, moving around the Earth. Mathematically, they're identical, except for the distant stars and parallax. But this brings me to the final question. The question that I think motivates why I'm wanting to look at Galileo as a scientist and pointing out the flaws, because he also did a lot of tremendous things. It's real easy to see Galileo as a villain. He hated anyone who copied his ideas, but as Hilbrun puts, whenever you've got a new idea in Galileo's writings, it's wise to look for it in that crazy monk Sarpi's notebooks. He got a lot of ideas from his teachers. He distrusted authority, yeah, right. But he was taught by his teachers, even his father, to distrust authority. On the authority of his teachers, he's distrusting authority. I hope you see the irony. He was furious at friends who turned their backs on him, but he himself abandoned his friends, his patron, even his mistress in Venice. It's real easy to say that he was a blowhard, that he was guilty of the very things that he accused other people of doing. And yet, unlike anybody else who looked through a telescope at that time, when he looked, he understood what he was seeing. What's more, he understood why it mattered. Lots of people would have had telescopes, and eventually somebody would have looked at Jupiter and somebody would have looked at the moon. Galileo was the one who had the vision and the breadth of understanding to realize what it was that he was seeing. He also was one who realized why it was important to tell the world. It wasn't enough to write books in obscure and hard-to-read Latin, like Kepler did. He wrote in Italian for the whole world to see. He was witty about it. He was generous about it. He shared his ideas with everyone. Of course, he loved the attention, and he made his money selling these books. But the real desire was to tell the world, to show the world. And this is a generosity and spirit that a lot of scientists then or now don't have. For all that, he abandoned their mother, his children loved him. especially Virginia, the eldest, who became a nun. And if you ever have a chance to read Galileo's Daughter by Deva Sobel, you have a sense of who she was and how close she and her father were. His students, including, I mentioned those Benedictine monks, cherished him deeply, defended him ferociously. And it's also interesting to note that after the trial, there were ways he could have escaped. He got to go back to his home in Florence. It was house arrest, but he was in his 70s and infirm by then. He wasn't going to go anywhere. But if he wanted to, he could have fled. While he was at that house, he was able to continue to write. He was able to continue to write books. And, his last book on physics was published outside of Italy, but that just meant that he had no trouble getting outside of Italy. In spite of that, he remained faithful to his city. He remained faithful to his church. Galileo was a complicated guy, which is to say, he was a scientist, just like the rest of us. Someone who we could admire, someone who we can appreciate, someone who will make you shake your heads in despair at times, and other times just be amazed at what a brilliant man he was. In some way, in spite of, the problems he had with the church, he's an inspiration for us at the Vatican Observatory. And I thank you very, very much for letting me speak to you and for showing my little film here. And if you want to know more about the Vatican Observatory, including a lot of articles that we have about Galileo, I encourage you to go to our website, vaticanobservatory.org.